Hi, my name is Martina Padrina, and I'll be discussing and comparing the molecular orbital diagrams of N2- and N2+. I had already filled out the atomic orbitals for both N- and N, keeping in mind that the negative charge on the N on the left is because an electron was gained. With this, the N- and N atomic orbitals, when they bond, they will form a bonding orbital which is at lower energy, for example, sigma 1s, and antibonding orbitals, which are at higher energy, for example, sigma star 1s. Therefore, starting from 1s, we will get one electron from the N-1s atomic orbital and another electron from the N-1s atomic orbital. This can also apply to sigma star 1s, as there is one more electron in the N-1s atomic orbital and one more electron in the N-1s atomic orbital. As stated previously, as the N- and N atomic orbitals bond, they will form bonding orbitals, which is right here, the sigma 1s, which is at lower energy, and antibonding orbitals, which are at higher energy, which in this case is sigma star 1s. The same will apply to sigma 2s and sigma star 2s, as there is one electron in the N-2s atomic orbital and another electron in the N2s atomic orbital, and one more electron into the sigma star 2s orbital from the N- and another electron in the sigma star 2s from the N. It is important to also note that you must fill up the bonding orbital first, as they are at the lower energy in comparison to the antibonding orbital, which are at higher energy. It is also important to note the molecular orbital's order for the 2p orbital. Due to the fact that N has a large 2s, 2px interaction, the pi bonds are lower in the molecular orbital, which I had written down here. As stated previously, the negative charge on the left N means that one electron is gained. So in comparison to N, which has 3 electrons in the 2p level, N- has 4 electrons in the 2p level. First, we will fill in our pi 2p levels, and we will completely fill them. So 1, 2, 3, 4. We will also completely fill the sigma 2p levels as well. 1, 2. And in this case, 1, 2, 3, 4, 5, 6. There is one more electron total between the N- and N atomic orbitals, which would go directly up to the pi star 2px. In regards to the bond order, I had already circled the electrons in the bonding orbitals and the electrons in the antibonding orbitals, which comes out to 2.5. The same will apply for the molecular orbital diagram for N2+. However, due to the positive charge, one electron is lost from the 2p level for the left. In this case, 2 electrons will be in the 2p level in comparison to 3. With this being said, also, in the molecular orbital for N2+, only one electron will be filled in for the sigma 2pz bonding orbital. Again, in regards to the bond order, I had circled the electrons in the bonding orbitals in purple and the ones in the antibonding orbitals in pink. From the equation for the bond order, I had gotten 2.5, which in comparison to N2- is the same. As the bond orders are both 2.5, the bond lengths and bond strengths are the same, as there are no differences between the two. However, N2+ is more stable than N2- due to the fact that N2- has more antibonding electrons. You can see this clearly in the molecular orbital diagram of N2-, as there is one antibonding electron in the pi star 2px antibonding orbital. And in the N2+ molecular orbital diagram, there are no antibonding electrons in the molecular orbital for 2p, neither in the sigma star or pi star 2p.